Alright, so this video is to show you how we can connect a inverting amplifier using the operational amplifier 741, which has been shown here. So this particular operational amplifier has got two inputs, pin number 2 and pin number 3, which are the inverting input and non-inverting input. Apart from this, pin number 6 is the output, and you have two more pins, pin number 4 and pin number 7. Pin number 7 you have to connect plus VCC, and pin number 4 you have to connect minus VCC. That means you need two power supplies. Okay, we have already one power supply on the breadboard. That's here. We have a red line where you have 5 volt, and there is a blue line which is negative. Okay, so with respect to blue, you have 5 volt on this red line. So we are going to use this as one source of the power supply. For another one, we are going to use the battery. You have a 9 volt battery already with a battery connector. What we will do is we will take two equal resistance of 1 k and make a series connections like this. To this series resistance, we will connect a 9 volt battery as shown here. Alright, so with respect to, let me put some labels here. Let's call this is A, this is B, and this is C. So with respect to B, the point C is negative, and this is going to be connected to pin number 4. Pin number 4. Alright, and apart from this, you have already two wires. You have a red wire on the board. You also got a blue wire. So with respect to blue, here we have 5 volt. So this is going to be connected to pin number 7. Okay, so pin number 7, you got 5 volt, this is plus 5 volt, and pin number 4 you got minus 5 volt. Okay, and this blue and this will join together. So this is your common terminal. Okay, so with respect to here you have plus 5 volt, with respect to here you have minus 5 volt, which has been connected to pin number 7 and pin number 4 respectively. Okay, so this is the connection for the power supply. Now, in order to make a inverting amplifier, we have to have two resistance. This 2K, let's call it RF, and this is RI. This 2K is going to be connected between pin number 6 pin number 6. This is just to show there is no connection between these two lines. Between pin number 6 and pin number 2, we have connected this 2K, and 1K has been connected here. Okay, and here we are going to give the signal through the function generator. So what will you do on pin number 3? Just connect it to common terminal. So let me indicate it with the ground. This means you are going to connect this one to here, this one. Okay, so instead of to avoid all this crossover, I have just indicated this as a common terminal. This also will be connected to the same point. So negative of the function generator, pin number 3, all of them are connected to the same point where blue and this B is connected together. Alright. So now the connections are complete. This is how it's going to be connected. So we'll give the input here as shown here. We'll give the input here, and we'll measure the output on 6. Okay. So what do we expect here? For this particular circuit, the gain is given by minus RF by RI. So RF is equal to 2 kilo ohm and RI is equal to 1 kilo. So it should be 2. Gain is 2. That means If you give a signal of amplitude 2 here, 2 amplitude, and the output you should get, this is multiplied by 2, it's going to be 4. So this is what we expect from this circuit. And also this is going to be inverted. Minus means it's going to be inverted. If the input is like this, output is going to be it's going to be just inverted, okay? Going to be just inverted. So this is how output is going to be. Relationship between input and output is going to be like this. All right. So let me complete the circuit using the simulation. You can complete the circuit. Alright, now I have completed the connection. Just explain what I did. As explained, the power has been connected with the 5 volt, plus 5 has been connected to 7, and minus 5 has been connected to 4, and the common terminal between these has been connected to, this is going to be the common terminal. Two resistors of 2K and 1K has been connected from 6 to 2, which is the inverting input, and also another 1K is coming to the same point. So this is basically the wiring details, and pin number 3 has to be connected to the ground. Now in order to give the input signal, I have used a function generator. If you look at the details of the function generator, I have selected this one to be frequency 1 kilohertz, amplitude is to be 1 volt. You can rotate, you see, you can change it like this, okay, or you can do this also, or 997 millivolt, 1 volt, right, 1 volt peak to peak, okay. So this is how the signal is being connected. You have to connect it here. That means input has to be taken from here, from this, okay. So this is how the input is being connected. So a sine wave of 1 volt peak to peak, and the frequency 1 kilohertz is being used as the input signal. On the output, since the gain is 2 as explained here, we should get 2 volt output over here, because it has to amplify the signal, right? So in order to see the signal, I am using a function, I am using an oscilloscope. Channel 1 of the oscilloscope is being connected. This is the channel 1. This is a 2-channel oscilloscope. So you can see, that means you can view 2 signals simultaneously. So I am connecting channel 1 to the output here, and channel 2 I am connecting to the inputs. Look at this. This has been connected to the input. Just for us to view both signals at the same time. Okay. Now, since I completed the connection as explained, let me do the simulation. I hope you understood the connection, right? Yeah. Let me run the simulation here. You need to switch on the oscilloscope. You also have to switch on this. See, you can switch off and switch on, right? So you select the signal, then you set the frequency to be like this. Frequency 1 kilohertz, amplitude 1 volt, and so on. Here you have to switch on the oscilloscope. Okay. Now both channels are on. See, channel 1 off and on and so on. See, now it is on. Channel 2 off and on. Okay. Now I'll start running this. Now you just click on the auto scale. Okay, here is the signal. So what you see here is, look at it, just click on the quick measure here, and source 1, and if you look at this here, channel 1, it is vertically it is 500 millivolt. So this is look at this. This is channel 2, which is showing the input. I can change the position of this. Okay, I can bring it up or bring it down and so on. I'll keep it in the center. Okay, the first thing that we can notice here is, when you look at the signal, first thing that we notice here is this channel 1, channel 2, which is showing the input, it is like how many divisions from here to here? Vertically, 2 divisions, right? 1, 2 division, right? Each division is how much? 500 millivolt. Here, 500 millivolt. So 500 millivolt and 2 division means 500 into 2, right? It's equal to 1 volt. This is the input. Whereas if you look at the output, this is output from this signal. This is the output, right? If you look at this, this takes how many divisions? 4 divisions. From here, 1, 2, 3, 4. This is the total height. Okay. From upper peak to lower peak, how many divisions? 1, 2, 3, 4 divisions, right? And each division is 500 millivolt. So 4 into 500, which is equal to 2 volt. Correct? So the relationship between the input and output, its input is 1 volt, output you are getting 2 volt. And another thing that you have to take note here is, if you look at if you compare both, when this one is going up, when the input is going down, output is going up. So that means this is inverted. Okay. So output is minus input into 2. This what? Minus means inverted, right? So what we are getting is exactly what has been expected. Since we have wired an inverting amplifier, output is inverted compared to input, and plus it is amplified by 2. Gain is equal to what is the formula for gain in this case? In the case of a inverting amplifier, gain is equal to minus RF by RI, which is equal, RF is equal to 2 kilo ohm and RI is equal to 1 kilo ohm, which is equal to 2. Okay, our input is 1 volt. This is the input from here to here. This is the height of this input is 1 volt, right? Because each of them is 500 millivolt. Each division is 500. Each division vertically is 500 millivolt. So 2 division means 1 volt, and output is 2 volt. This is output from here to here. This is output 2 volt. Okay, so we are getting an output which is exactly as expected from inverting amplifier.